All right, welcome to The Explainer. Today, we are diving into a really fascinating and honestly pretty controversial idea. It's a hypothesis that basically questions the entire foundation of how we measure our planet's deep past. I mean, for more than 100 years, the answer has seemed pretty clear, right? We found it hidden in the rocks themselves, using this method that acts like an incredibly precise atomic clock. Now, this whole method, it hinges on one massive assumption, and that is that the ticking of this atomic clock, the rate of radioactive decay, has been absolutely, perfectly constant throughout all of history, no matter what. So, the source material we're digging into today throws a real curveball. It puts forward this super radical idea. What if that fundamental constant of physics isn't so constant after all? Okay, let's get into it. So the first chapter in this whole scientific detective story starts with a mystery, what look like some serious cracks in our geological timeline. You see, the source we're looking at argues that the dating record isn't nearly as neat and tidy as you might think. It actually points to published papers where scientists themselves have admitted to, well, throwing out results that just don't fit the age they were expecting to find. And it's not just a hunch. The source highlights some really puzzling findings. I'm talking about things like carbon-14, which, should be long gone after just thousands of years, showing up in dinosaur fossils, or finding perfectly preserved soft tissues in fossils that are supposed to be millions of years old. And then there's this. You have rocks sitting right next to each other that give you wildly different radiometric ages. It just doesn't add up. So, okay, if the clock really does have cracks, then what in the world could be powerful enough to break it? Well, the source proposes a suspect of truly cosmic proportions. The whole hypothesis really centers on the just unimaginable energy of giant asteroid impacts. I mean, look at this number. That's the estimated energy from the Vredefort impact in South Africa. And to put that in perspective, that is an energy blast so immense, it's orders of magnitude greater than the energy that holds the very nucleus of an atom together. Just wow. So here's the absolute crux of the argument. The idea is that these impacts don't just dig a big hole in the ground. No, the source is suggesting they create conditions so extreme they can physically change the properties of matter itself, essentially resetting or flash aging the rocks in mere milliseconds. Okay, but how? I mean, how exactly could a giant rock hitting another giant rock actually change the fundamental laws of nuclear physics? That's the big question, right? So let's look at the mechanism this hypothesis proposes. Okay, check this out, because this is where things get really wild. For just a few milliseconds, the Vredefort impact is theorized to have created a local plasma environment with temperatures and densities that could actually rival the very core of our sun, a tiny temporary sun right here on Earth. So the source breaks it down into this crazy chain reaction. First, you get the hypervelocity impact, generating just unbelievable pressure. This extreme pressure then creates that high-density superhot plasma we just talked about. And then, inside that plasma, electrons are packed so tightly around atomic nuclei that the whole environment can dramatically speed up radioactive decay. It's like the normal rules just get thrown out the window for a moment. And it doesn't stop there. The source also points to this other, really controversial idea called piezonuclear fission. The theory here is that extreme mechanical pressure, just squeezing something hard enough, could actually trigger nuclear reactions. So you have that, plus other effects, and altogether it's presented as this whole suite of ways that an impact could create what look like false age signatures in the rocks. So if, and it's a big if, but if this hypothesis holds any water, the implications are just staggering. I mean, it suggests a completely different way of reading our planet's entire history. And this slide really lays out the two competing ideas perfectly. You have uniformitarianism on one side, that's the classic view, that the present is the key to the past, and everything happens slowly, gradually, over eons. But on the other side, you have this idea of catastrophism, where the past was shaped by these unique, unbelievably violent events that could even change the physical rates we thought were constant. And with this new model, you get a radical reinterpretation of, well, everything. Those vast layers you see in the Grand Canyon, maybe not laid down over millions of years, but slammed into place rapidly by global mega tsunamis kicked up by impacts. The fossil record, not a slow timeline of evolution, but a chaotic sorting of creatures based on where they lived and how they got buried during a catastrophe. And that high radioactivity in some of the oldest rock layers, maybe that's the leftover signature of these nuclear-altering impacts. And believe it or not,
The consequences might even extend beyond just rocks and into our own biology. The source even suggests that a really recent and kind of mysterious peak in human mutations, happening about 5,000 to 10,000 years ago, could have been caused by the burst of radiation from these very impacts.
So, in the end, this whole hypothesis challenges us to think about a history written not by the slow, steady ticking of an atomic clock, but by the sudden, violent strike of a cosmic hammer. It really leaves us with a pretty provocative question, doesn't it? Could these cosmic catastrophes not only shape our world, but also completely rewrite the very clocks we use to understand its history? It definitely makes you think about how we know what we think we know about our own planet's past.